Hello, welcome back. We're going to be working on our inventory system a bit more today. I was thinking about all the ways we did it wrong yesterday, but I still don't have a good way to do it. Right now we've got 3 items instantiated with quantity of 20 up here in our pause state. I think what I want to do is change it so that we're not... Let's see, look. We have a global inventory that gets an inventory instantiation here. We have a G items, global items, and then where are we doing? Is it in our pause state? Our pause state is rendering our inventory. I don't see where we're inserting the items. Right here. Okay. It's in our inventory class. Okay. So yeah, I think the big issue here is I don't want to be doing... One, I don't like giving the grid location in the item instantiation. Ideally, we can instantiate the item in the specific grid and just have it be handled. But also... I feel like our inventory grid is off. I feel like right now what we're doing is putting an item instantiation into a 2D array, but I think we should have a 2D array inside of our inventory instantiation, if that makes sense. And then it would be... Like, we can do a 4x3 here in our inventory class, and the table can exist inside the inventory class as opposed to a global inventory system. So I think we can change how we did some stuff from yesterday's to clean up some of this mess. So let's see how we might do that. Instead of doing a 2D array of this global table inventory grid, I think what we want to be able to do is have like, maybe we can call this row length or something, because what I'm thinking is we give ourselves I think we give ourselves the table here, and what would happen is we can then... Hey, what's up, K-Tronics? How's it going? Good news about the channel. I sent the cut of the interview over to Craig for his sign-off, and he said we're good to go to post it. So I think this Friday I'll be scheduling a live stream of the interview, and then after that it'll live on the YouTube. So I'll schedule it for a premiere on YouTube, and oh shoot. But yeah, my Twitch stream is crashing, but yeah, the first interview for the channel is going to be live this Friday. So yeah, that it came out great. I'm super happy to share it with people. So hopefully people can enjoy it. So I think we'll keep rows and columns with a plural here. And then singular row and column will be how we index into... Wow, internet is just awful today. We'll see what it might look like. You know, if we keep crashing here, I'll just stop streaming and just record for YouTube, because it gets really sad when it just keeps crashing all day. So we'll give it another couple chances, but if it keeps crashing, I'll just call it quits on streaming and just record it. Ideally, what I want to be able to do is do we would need like a 2D array inside our inventory. So if we had like a dot grid, which is a table of all of the rows and columns, kind of like how we're doing in here, then we can then go into, for example, we would be able to go self.grid at the row and column. And this could be how we insert items. So like it might look something like this. Table.insert list and value, which would be an item. So I'm hoping we can get rid of the index for the row and column for the item, and instead put it in the grid table. And then what that means essentially is that we wouldn't necessarily render something at an item's location, but we would render an item at a grid's location, which makes more sense than what I was doing yesterday with this double instantiation grid location as well as 2D array location. So I think if we go about this route, just makes a little more sense. I think. So let's see if we can get something similar that we got yesterday, but with this new notation. It looks gross because there's a lot of self dot in there, but at the end of the day, it's a table called grid and a row and column, for which row and column of the inventory grid we're trying to render items to. So I think it does make sense. And then we would have to maybe do a certain check, right, for we only ever want one item to be stored at a certain grid location. So maybe we can implement some checks for that, but I am not sure. You know what, this is going to confuse me with the rows and columns. So like, I want to call it like row amount and column amount. That just is a little easier for me to wrap my head around, because if we're using .row, the S is going to throw me off. So we need to do something similar here, but for our grid. So we need to loop through our grid, and we can say for the amount of row amount we have, we want a column amount of things, right? Well, we want, first of all, we want our grid at inventory at index I to be given an empty table so that we can table.insert items into it. And then we want to loop through all of our columns for our column amount, and we want to self.grid at index IK give an empty table here. Man, we just keep crashing. That's a bummer. I'm gonna see, let's see. I'm gonna see if I can restart my internet from the phone here. Cause that's a bummer. And I gotta update my app. I pay too much for internet for this to happen so consistently. Okay, so let's say our row, I think our row is 3, or our row is 4, and our columns are 3. Let's just double check. I might just be calling it quits on streaming for tonight because it's just getting old real quick today. I'm not in a great high energy mood today. Yo, what is happening? Off to a weird start. Okay. So we lost our items because we are now doing it based on the grid table in our inventory class. I think it makes more sense to hold it in the object instead of global 2D arrays. So I think this is a good move. But what do I know? Okay. So we have a grid 2D array of the right size. So now we need to be able to do some special stuff in order to say, hey, why don't we give us an item instantiation right inside here? Now we won't ask for a row and column. It'll exist outside of a row and column. But we will know where to render it based on these two numbers, based on the row and column of the grid. So we should be able to find a way how to do that. But the thing is, the self row is the table, not the index. So we would, for example, if we want to put one at grid 1-1, we can say this. Go ahead, go into the first grid, the first row and first column, and insert a table instantiation which has a little baggy sprite as well as a 20 quantity, and go ahead and insert it. And then what we can do is we would cycle through all of our grid. So we would say for all of our self.row count, we would cycle through all of our column count for k equals 1 self column amount. We would want to then render the item that's in our grid, so self.grid at ik if it's not nil. So it would be this at index 1, meaning the first item that's in there, the only item hopefully that's in there, we would go ahead and render it if it isn't nil. So if we just try to run it now, it'll crash because grid this is because in our item class, where are we? We're using these parameters that we don't define anywhere, so we'll just take that out, make sure we're not rendering. Okay, so the item renders at a self X and self Y. So, okay. Yeah, we still have to fix which. This is jacked up. For right now, I think I don't want to do this old stuff. We'll have to figure this out. I feel like it's not figured out in the item class, but for right now, we'll say self X is 0, self Y is 0. And then we will see if we crash by rendering potentially a 1 index on a grid that doesn't have an item but is an empty table. And it does crash when we do that. So crashed at inventory 61, which is right where I thought it would. So we want to only render this if there is a value in there. So if self grid I don't know if we would put this and check for equality with nil, or if not nil. If not nil, then go ahead and render the thing that's in there. Okay, we've got a little baggie. So we want to render this baggie at the correct X and Y for whichever grid location it's in. So this is 1 1. 1 2 1 3 2 1 2 2 2 3 3 1 3 2 3 3 4 1 4 2 4 3. So when we go to render this, I don't know what the move is. We could update, because right now if we look at how to render an item, it is just rendering at an X and Y, its own X and own Y, which we instantiate to be 0. So I feel like once we insert it, maybe we modify. I don't like the idea of passing in the same row and column, but we might have to just modify it here. So like we give it. It's tough too, because if we imagine in the game, we only instantiate these once, but then they get moved over time as people play and switch items and stuff. They just get moved around. So I don't think I like the idea of it living in it. So maybe we can say how would we do this? We'd have to modify it whenever we decide, okay, an item is here now. We need to say here now means in X and Y width and height of a certain value. So I think we do want the parameters. It's just an easier way of saying which row and column the item goes in. But then again, it's in the 2D grid. So an item is only supposed to exist in a single grid. So we should be able to get away with modifying the X and Y position render based on. This is weird, yeah. I guess would we do it in the update? Because essentially we want to say that the self.x of whatever item is just updated to wherever its current position is in the 2D grid. So I feel like we might want something like this, where we would say, go ahead and cycle through all of our grids, and if there is an item in there, we don't want to render it, we want to update it. And we'll say that the update takes in an I and a K, a row and a column in which to update its X position. And then in the item class, we will come in here and say, okay, update takes in delta time. but also I and K. Can we do that? And then in here we would say update takes in delta time. We don't need our update to take in delta time actually, so yeah we do. No, we don't. I always just by default put delta time in the update function, but in this scope, in this inventory class, we're updating this inventory class, right? Inventory update. Actually, I don't think we're updating our inventory just yet. Let's see in our place state if we're updating our inventory. Yeah, we are not. So what we can do is in our update, we can just say, go ahead and take our inventory and update it. And then in our actual inventory, we can say, okay, now this is actually going to be running. Therefore, we're going to run update for the... When we run this update method, this is running the update method from our item class. So I want to say that we can get away with... Like, let's just try to say, okay, our X is going to be literally whatever our I is, and our Y is going to be whatever our K is. We could call it row and column, and we probably should, but I just want to see if this crashes or does anything weird. Okay, it doesn't. So it looks like we don't need to pass in I and K. It's just that, what if we were to say that this is 30 and this is 30? Does that update our X and Y for our item? It looks like it is. Okay. So now, instead of instantiating them at a weird thing, we're going to be updating... We're going to be updating its location based on an IK. So what we could do is say for... We could say for row, call, and then in here we can say row... let's do it this way. Row. Just to be a little easier to read than IK, you know. Okay. So we're going to cycle through, update all the items if they exist. And we pass in the row and column into our update function for our item, which will then defer to the update, which then we can call this. We can say that this is takes in row and call. Row and call. Okay. Okay. So whatever row and call we pass it. Right now we're just saying, okay, the X and Y is whatever we update our item with. So at this point it'll be like a 1-1 because we're inserting into the 1-1 grid row and call an item. So it's like, it's not exactly flush up to the left and very top, but we've got a little bit of gap here. So now the goal is to get the proper offset for which column it's supposed to be in or which row it's supposed to be in. So we can start easy with, like, maybe we know there's an offset. We don't want it to be so close to the left side of the screen, so maybe what we do is we say whatever the row is, we know we're just going to modify it by 20 for the X, and that's way too much. It's probably closer to 5. Let's just see what 5 pixels away from the left side of the screen looks like, and see if that's a good starting point for our first item. Maybe a bit further, maybe like 8. Let's see what 10 looks like, just because I like the nice round numbers. Okay, that looks good. Let's try to get our Y set up. So we need, like, this would be the offset, right? So let's see what 10 gets us. And this will be 10 plus 1, actually, but that looks maybe a bit too low. So we'll change our, these will be our constants to modify like the offset for our X and Y, but then we'll need to do some arithmetic for how many rows we're in, modify it, you know, every row is, or every column is 20 pixels farther from the previous, so we can go and do some arithmetic in there. So if we say 0, 0 on the update, then we can see what if our offsets are looking good. Yeah, it looks pretty good. Other than the, you know, programmer art. This red box is not indicative of anything, so I'll probably just turn it off. I think it was so I can see other things better. Maybe what we'll do is we'll just color it 10 and make it space a bit more. Let's make it we'll make it pretty bright color, but we'll stretch it a bit. Height is just gonna get taller by a couple. This is, we don't need this for anything more than kind of planning purposes, so okay, that looks weird, but I think it's because it's not transparent. It should be, or it is transparent. It should be, we're just going to do a light color, fully opaque, not as far downwards. Cool. Okay. Well, now it's harder to see the white. We'll change in our item class the text to be black just so we can see it a bit better, and then we'll get our stuff working better. Okay. Okay, we need to do this only for the string. Okay, it looks bad, but that's okay. It looks better than the... whatever. We'll keep going. We'll keep chugging along. Okay, so if that's grid 1, 1, you know, maybe the move is we just render a rectangle of a given item width and height, and we give each of our grid an item, and then we can tweak them all at once and kind of see how the items lay out. So maybe in the item here we say that instead of doing a yeah, let me see. I think this is a good way to do it, which is like to set a color. We'll set it to blue. So R, G, and B, alpha. We'll give ourselves a blue color, and then we'll render a rectangle of an item size. So our item size is a 16 by 16, but there's gonna be some gap. We know it's gonna be wider than that. So let's say the X and Y is our current items X and Y, but then our width and height is, let's just say 32 for a width, and let's say 24 for a height, and see what that looks like for a single blue rectangle where our item 1 is. Okay, so this is helping us kind of visualize where the rows and columns are, because this blue is sitting in for a item. So I think this is too much. I think we want it, let's say 28 and maybe 20. Okay, so next step is to give our grid a complete, every 2D, every table of our 2D grid needs to have an item. So we're looking for 4 times 3, so 12 blue rectangles. But we would have to modify, this by a certain amount in order for us to see them. Because right now they're, well, yeah, we want to say that it's a row times the width. And now this is a little jacked up because we don't want to modify the row. We don't want to modify an X offset if the row's 1. We just want to modify how do we do this? If row is 1, then we just want to add the offset. So we'd want to say, okay, if row's 1, then our y is going to be equal to just whatever our neutral offset is. And then same thing for our column. If our column's equal to 1, then we're going to say, okay, well, our x is going to be the offset that we've already seen. This offset that we've got. So if row is not 1, we can say else our y is going to be equal to column times the width of our rows, or the height of our rows, but we want to subtract the offset so that we are a consistent space apart from each other. I think. So we're gonna say row times, I'll just put times 10 like the other one. We'll have to tweak these, but I also want to offset. Okay, so like let's walk through this. If it's, let's just talk about 1, 1. Then x and y will be, x will be 10, y will be 8 because it's row 1, 1. Let's just focus on x. So on grid 1, it'll be an x of 10 because of the offset. Now on a column of 2, it's going to come here and say, okay, well now it's 2 times 10, which is 20, but we minus a 10, so it's 10, but that's the same row. That's the same one. Okay, so maybe if we don't do this offset, then column 1 becomes equal to technically 11 because we're adding the 1. So we wouldn't add row, we would just say we're equal to the offset. That's our x. Then on the second row, we would say, okay, well now it's 2 times 10 because it's, now the 10 isn't the same offset, but it's going to be, yeah, I think we need to add the offset for the consistency. So like we'll make constants here. We can say that this is just x offset because this is getting confusing. Y offset. Right now, y is 8 and x is 10, so we can come in here and say that this is our y offset. This is our y offset. I really did spell it offest. And then this is our x offset here. And this would be our x offset. Okay. So on a column 1, we just get the x offset so that we're flush with whatever offset we define. On row 2, we would say, okay, 2 times the width of our item. So 2 times 10, which would be 20, plus our offset. Because 2 times 10 would be 20, plus offset of 10, which is 30. So it would go 10, 30, which is a difference of 20. And on row 3, it would be 3 times 10, which is 30, plus offset, which is 40. So it would go 10, 20, or 10, 20, 40. Yeah, that's wrong, huh? Wait, let me just see. Like 1 is equal to 10, because our x is just our x offset. 2 would be equal to 2 times row, so 2 times 10, which would be 20, plus 10, which is 30. So we'd go from 10 to 30, which is a 20 difference. And then on 3, it would be 3 times 10, which is 30, plus our offset, which is 40. Yeah, so then we go from an x of 10 to 30 to 40. That maps with the incorrect thing that we saw yesterday. So we have to say, yeah, what if we modify them all by the offset, and then we say, then it's just a width. So we would say we want to plus our row. Let's say that this is row plus our offset. We're modifying each one by the offset. So on row 1, and this is weird. We want to do a row times a width. Yeah, yeah. Oh, fuck. The one indexing is screwing us here, and I'm just a little stumped. It should be easy. We want a consistent difference between them, but maybe if row is equal to 1, we just do the offset. Then we want an offset plus a width. It's almost like we have to subtract one item from this one. It's like we would multiply it by 10, but then we'd subtract the width of one item to offset our one index. That looks so weird. But let's walk this through. 1 would be 10 because it's x offset. 2 would be 2 times 10, which is 20, plus x offset, which is 10, minus a 10, which is 20. And then 3 times 10 is 30, plus x offset, which is 10, which is 40, but we have to minus the width, which is 30. That gives us 10, 20, 30, so a consistent distance between each one. Okay, so I think we want something like that. It's just that we'd want to modify the y by the height of our item. So this 10 would be like a width, item width. This 10 would be an item height. And then we have to make sure our y is just our y offset. And then maybe we're in business. Okay, so let's just manually place an item at 1, 2, and 3 and just see if it looks right, and then we'll worry about getting a whole list of items. So we'll go into our inventory and we'll say in our update function, let's see what 1, 1 looks like, and we can tweak our x and y offsets as needed, but here is an item at 1, 1 on our grid. It's that blue circle, 1, 1. Let's see what same row but next column over looks like. Hopefully it moves to the right, like by a whole item width. Shit. Oh no. Looked like it didn't move at all. We might not be updating our inventory because this has to be... Oh, our item has to be updated. Okay, yeah, and that's what we are updating. In our inventory, yep, this method of update is being called on the item itself because that's what's in the row and column. Oh, but Okay, no, this is okay. It's just that this isn't getting modified. This isn't getting... Whatever parameters we pass in the update isn't moving it, which is bad. We are modifying our X and Y. Let's just say for testing purposes, we say, okay, well, our X is actually 40 and our Y is actually 40. We should see a blue rectangle elsewhere. And it is. Okay, so our logic is not working here somewhere. Oh, if our row and column is 1... Let's try... This might be Y. Let's try to put 2, 2. Let's see where this renders. Oh, not good at all. It is different. It is moved. It's just like so wrong. And 4, 4, where is that? Okay, that's super tiny, but maybe that's okay. Let's walk through this. If we're a row 1, our Y is just going to be the Y offset, which is 8. Okay. Else, if row is not equal to 1, then we get whatever column. Oh, see, this should be row, right? Y is going to get... Yeah, why would we be doing... Okay. If we're on the first row, otherwise our row is going to be the row times 10 minus the Y offset, and this should be column, I want to say. Yeah, because our row determines how high up and down we are, so that's our Y, and our column is what X we are, so that is looking more correct. But they were being modified by the same offset, so still looks jacked up. So 4, 4, and if we go to 1, 1, it looks okay, and then if we go to 1, 2, it looks over just a bit. Okay, so let's modify our item width a bit more. So let's define 2 more locals as like item width. And we're going to say item width is actually 25. And in item height is something like 30. And then we can say if we're modifying the row, we want to offset by the height. And if we're modifying the X, we want to modify by our width. So we can substitute every 10 for item width. Okay. Let's see that. Where is 2? That looks, yeah, that looks good. That looks in the center of our thing. Okay. So now let's try 3. It should be at the right side of our little grid here. Yes. Okay. So I guess the move now is like we need to check the Y's also, right? So the rows, if it's a row 2, is it look about the same height to fit 4? That needs to be higher. So we can modify our height to be higher. Okay. And then let's see what our... Oh, that's... Okay. Our row of 3... Okay, that's looking okay. And then row 4 might be too low. Yeah, too low. So we're going to come and say height is actually 35 maybe, and see where that leaves our row 4 item. Okay. That's looking a lot closer. We can afford a little less on the height. And I think a little more on the width. That looks good for height, but we can go a little more on the width to spread out to be all the way to the right side of our grid here. That looks good. Okay, so that's That's 3. No, that is 4, 4, 3. So fourth row. Oops. Yeah, that's fourth row, third column. So that's looking good. And then if we go and try to do something like, let's make sure 1, 1 is looking okay. Yep, that looks good. And then 2, 1 should be right below that. Nice. It doesn't look like it's getting offset by the right amount. Oh yeah, see? 1 and 2 look a lot closer. Okay, so I think we're at a good spot now where we can put more than one item in there so that we can see where all the items are. Because now, if we update each item with a corresponding row and column value, they won't be in the same place. We just need to give ourselves more items so that we can render them. So I think in our inventory, you know, we're only updating manually by a row and column, but we want to come in here and say we want to put an item at every grid. So we can come in here and say once we have a 2D array, we're going to insert into that 2D array an item instantiation. So every grid will have an item in there, but then we need to update each item. We're saying for each row and each column in that row, if there is a value inside that grid, which there are now for each one of them, all 12, we should be able to say, okay, that row, that column, at the first index, the only item that's in there, we want to update with the row value and the column value. So now we should see, and we are rendering every item in the 2D array. So we should see 12 blue squares at this point. Okay, see, this is what I was worried about. Yeah, see how the first two are too close. The columns are looking good. Those look pretty spaced appropriately. It's just the rows that aren't spaced appropriately. So in our item, our row is not set. Item height. Okay, if row is 1, we just get the offset. If row is 2, we would say 2 times the height. Height is 34, minus a y offset, minus 1 item height, so that we subtract for the offset. If we didn't do this height offset, what happens? It's still, yeah, we have to subtract for that y offset because we're getting consistent spaces for the 2, 3, and 4 rows, but not for the first row, or for the second row, the first row after our initial row. So we do have to minus an item height here. I just don't get why it's not even like the other one. Okay, let's walk through. Let's pretend item height is really 10 to make the math easy. Then we're gonna do, you know, if row is 1, offset is 1. So at 1, just literally walk through the math so I can see the pattern. On 1, we just get the offset, which is 10. On 2, we get the row, which is 2, times item height, which is, we're saying for example's sake, it's 10. So 10 times 2 is 20, minus an offset, which is 10, minus an item height, which is another 10 that we're subtracting. Yeah, so that gives us, what? That gives us 0? That's the issue. Well, let's keep walking through. Row 3 times item height, which is 30, minus a y offset, which is 10. minus an item height, which is 10, which gives us a total of 10. So we have a 10, 0, and 10 on the Y. Yeah, this is jacked up. Okay, so we want... I'm just like, I've got to see the pattern in my brain, right? Like 40, because it's the fourth row, minus 10 for the Y offset, minus 10 for the item height. That gives us 20. So yeah, these ones were all 10 apart, but this two are 20 apart. So yeah, it is wrong. So how do we get the first one to be 10 higher than this one, and every subsequent one being 10 higher? But the 10 is actually just the item height, which is variable. So we need to put... Yo, why did it work? Why did it work for this one? It worked for the X, didn't it? Let's make our width a little smaller. Let's make our width like 10 pixels and see if our column is actually correct. Yeah, see, our columns are evenly spaced. Okay. And we're doing a column times height minus a Y offset. Is that where we're messing up? Why are we adding an X? Oh, we do have to add the offset, not subtract it. Okay, let's see if that gets us where we're going. Yeah. Okay, yes. So now the item height is too much because we're creeping into the bottom there. So we'll shrink the width of our blue circles or squares, but then we'll get our height to be smaller because now that we're doing the proper math, it is wrong. So let's see 30 on the height, and let's see what that gives us. Nice, look at that. Yes, we've got a little inventory. Okay, I think the Y offset is a bit too much. This is much better than the last way. We do need to, it's a little bit, need to split the difference on 6. Sweet. Okay. Okay, sweet. So now instead of the 20, let's try to get our... we won't render our rectangle. We'll just render our image and the quantity. Sweet. So we got little 20. We can offset this so we can read it better. So maybe 5 and 5. Look at that. Okay, great. Great, great, great. Okay, so what I like much more about this implementation is we can change the grid adaptively by just swapping the height and stuff in our item class. So like we can come in here and say, you know what? Those are way too wide. I actually want a grid of 4 and 5 or whatever, and we can shrink it down and we could squish them together. Not, you know, that doesn't look good. We won't have that many items, but with one change of a button, we can adaptively change it versus we would have had to do with our old method we started yesterday. We'd have to reinstantiate each item at a different X and Y or tweak it differently, and that wasn't very scalable. So now at least we can resize and tweak as needed. So that is a big step in the right direction, I think. Sweet. Okay, so I think I want to get this inventory rendering upon a button press for our mobile deployment, so that it's not just an enter. And right now this is actually not right. Yeah, see, because enter is read assign, so right now we can't read assign without pausing first. So read assign will be turned into an A press, which will be turned into a P press, I guess, on desktop, if O and P are our A and B buttons. I haven't quite decided that yet, but if we can get our little inventory system, so like with our inventory here, we can see that it's not just rendering willy-nilly, it's rendering based on the items here. So like if we were to remove an item from, let's say we can say table.remove, and we want to remove from the list of our self.grid, let's say we just want to take out the second item. So row 1, column 2, index 1, we just want to remove the value, which, oh shit, how do we do that? Can we just say remove? Shoot, I don't know how to do that. We have to give it table.remove. Oh, position. Okay, yeah, position, not value. So yeah, position, we're going to say the table that's here, but the index of 1. And that's what we want to remove. Therefore, we took out one of our items in there. So this kind of proves that we can manually adjust the items. And what's kind of cool about this is like all of our items are only in one grid. I mean, well, yeah, in our inventory object, we have a grid, and that grid holds a 2D array of all the items. So I think this is okay. This is cool that can work. Okay, so we need to add the ability, if we press the start button on our mobile deployment, I want inventory to pop up. So let's see how we're toggling our inventory state. It's actually called pause state. Where right now we're only toggling pause state upon a enter press. And we're only coming back from a pause state with an enter press. So we need to check our touch table and stuff for this, which is tricky because I think our touch detection, oh, let's see. I think anytime we've done touch was in our play state, so no? Where do we do? Okay, our touch handling class has this. Okay. So I think what we need to do soon is, like we're handling our touches, we have like this input list and then output list of all the inputs. And the output list is the cleansed inputs. So it's like input list is the raw, whatever's being pressed on the D-pad. Then the output list is like, okay, which of those inputs do we actually care about? If they're contradicting, then we just weren't going to delete them, and we're only left with nice directions. We need to do the similar thing with our button table so that we have access to a global button table that has a list of all of our cleansed button outputs, which we only really have to cleanse the input for the D-pad because there's contradictory stuff. If start is pressed, we know we want to trigger a pause state if we're not paused, and trigger a not pause if we are paused. So we need to put those values in a button global table, like we're putting our directions into our touch output list. So touch output list should have probably been called D-pad output list, so that we can also have a button output list. So that'll be next. I'm just a little low on energy today, so I'm going to call it a night. We did get our inventory up here, which is really nice. So it's going to be nice to start implementing this and then have it on touch as well. So yeah, it's gonna be a lot. The inventory system's already taking longer than I was thinking. Or like it's more complicated than I was thinking. I've had to dumb it down, and even the dumbed down version is tricky. So we'll keep going. This is exciting. This is looking good. And once this is going, we have to worry about saving, right? Because we have to maintain continuity with your inventory over multiple play sessions. So that'll get interesting too. I've done saving and loading once before on a high score in Joust when I made that. So I'm not too worried about that. I just don't know anything about the strategy of building it, like architecture-wise, how to organize all that data. Not exactly sure, but this is good. This is coming up nicely. Gonna say that we added added 12 items in inventory, rendering based on grid location, which is huge. So all we have to do is make sure the item is in the correct grid location and it'll render at the correct spot. So that is nice. Okay. And then on Friday, probably, I don't know what time, maybe at 6 p.m. Mountain, I'll schedule the release of the interview I did with Craig Lepero for, he made PTN Ninja, which is a program for portable TAC notation. And TAC is a video game from one of my favorite books. And I made a TAC implementation, and I found Craig, and he blew me away with how good his program was. So I have an hour-long interview coming out with him for the channel. It'll be streamed on Twitch and also posted on YouTube. So I think I'm going to say that it's coming out Friday, 6 p.m. Mountain, and then I plan to live stream after it, doing game dev stuff. So that's the current plan, and it'll be on YouTube if y'all missed the live stream. But I'll raid out here. Let's see. We've got Basie. So we'll raid out to Basie. I hope everyone has a good night. Thanks for watching, and I'll catch you tomorrow. But yeah, have a good night.